Hello students, now we will start with new topic, that is Michaelis-Menten equation. We know that when substrate concentration is increased in an enzymatic reaction, then up to one level the reaction will be in forwarded state, and later the reaction will be, it is not stopped because after reaching enzyme and substrate complex, then it has to give the products. So the reaction will be temporarily decreased. The formation of enzyme substrate complex will be stopped, but the reaction is still forwarded in a steady state plateau to give out the products. To explain this total concept, basing on the increasing of the substrate concentration and availability of the active sites of the enzymes, generally we write like enzyme plus a substrate gives enzyme substrate complex, which again gives out products, plus when products are formed, all the active sites are now relieved from the substrate molecules. So now enzymes with free active sites are separated. This enzyme substrate complex, it is having a nature to again dissociate back into enzymes and substrates. So it is represented with reversible arrow mark. Now enzyme plus substrate, when it is forwarding the reaction, we write as K1 or Kf. It means the rate of the reaction is forwarding. After formation of enzyme substrate complex till the formation of products, it is represented with K2. Here K means the reaction state. Now this enzyme substrate complex, it can easily dissociate back into enzymes plus substrates. Again we are representing this one with K1, but we are representing this K1 in denominator place. So the numerator K1 means the forwarding reaction, the denominator K1 means the reversible reaction. What is then Michaelis-Menten equation? If we directly go for equation, we write as initial velocity of the reaction is equal to maximum velocity of substrates next to the Km value plus again the substrates. Here of this word we used to replace with multiplication symbol. Now what is V0? V0 indicates initial velocity of the enzymatic reaction at particular time or at time t. Vmax means maximum velocity of the enzymatic reaction. Then what is Km? Km we used to represent in two places separately. That is, when we are talking about enzyme, we used to represent Km as Km indicates the affinity of the enzyme towards the substrate. In other words, when we are talking about concentration of the substrate, we used to tell Km represents the concentration of the substrate that allows Km to reach half of the velocity or the concentration velocity of the enzymatic reaction, or Km in terms of substrate, it indicates concentration of the substrates that have occupied half of the active sites. So we'll write that one in two different terms. Km indicates affinity of enzyme towards substrates. Next, Km can also be concentration of the substrates that have occupied half of the active sites of enzymes. S indicates nothing but concentration of substrates. Simply means the total number of substrates that are involved in the reaction. Now we will see in detail about all these points once again. Equation here, enzyme plus substrate, enzyme substrate complex and products in the form of a graph. We take this upper vertical arrow mark for indicating rate of reaction, or velocity of reaction, enzymatic reaction. On x-axis, this is y-axis. On x-axis, we represent increasing state of, means increasing substrate concentration, or increasing of substrates concentration. So this one I can represent here once, enzyme plus substrate that have started initially. The reaction gets started, forwarded, and has reached one state of enzyme substrate complex. Later, though we add more number of substrates, since the active sites of the enzymes are not freely available, the reaction is not going to give us a linear graph like this straightly, but it is giving now a steady state which gives at the end products. Plus enzymes get separated. Now, the graph which is growing or representing horizontally, it is called as steady state of the reaction or steady state of the graph. Steady state of the graph. There is a lot to discuss about this enzyme substrate complex. This is the point where enzymes have been completely occupied by the substrates at enzymes active sites. This also indicates this is the place where enzyme substrate complex has formed, where enzyme has reached maximum of its velocity in the reaction. Enzyme substrate complex indicates the point where the velocity of reaction or enzymatic reaction has reached its maximum level. Enzyme substrate complex. What is name of this point where enzyme substrate complex has reached its maximum level? It is indicated with Vmax. We are indicating Vmax. Vmax means maximum velocity of the enzymatic reaction. Now, the value, numerical value of this and maximum velocity of the reaction is indicated straightly on y-axis. So here we represent the value of Vmax. This is the location where all enzymes and substrate complexes have been formed. But here there is no value. We are just seeing the increasing number. The values can be noted from the y-axis, which we are writing here as rate of enzymatic reaction. Now, this enzyme substrate complex or Vmax, it is influenced by three different factors, that is temperature, pH and enzyme concentration, not the substrate concentration. Vmax is influenced by temperature, pH and enzyme concentration. When enzyme is increased, then Vmax also will be increased. When enzyme concentration increases, then value of Vmax also increases. But when substrate concentration is increased, there is no effect or influence on velocity of the reaction, because by the time it has reached the maximum velocity, all the active sites of the enzymes are occupied by the substrates. So, when substrate concentration is increased, there is no effect on Vmax, that is maximum velocity of the enzymatic reaction. Is increased, there is no effect on Vmax. Next, after formation of enzyme substrate complex, we are seeing the product formation. This indicates turnover number also. So we can also write here as TON, which indicates turnover number. Already in the previous video, we have discussed what is turnover number. Again, we will see just the definition of turnover number. Turnover number indicates the number of substrates that are converted into the products in a particular time, means in a minute, by one single enzyme. So turnover number means the total number of, or the number of substrates that are available, of substrates that are converted into products in a minute by one single enzyme. By one single enzyme. This is nothing but the meaning of turnover number. So, to reach maximum velocity quickly in very less time, an enzyme should have its own half Vmax or Km. What does it mean? To reach an maximum velocity, an enzyme should have the substrate's binding nature in its active sites, means 50% of the active sites of the enzyme should be quickly get filled by the substrates. In how much time it is getting filled? Means how many less number of active sites, less number of substrates are binding to the active sites of the enzyme and proceeding the reaction. That must be half of the total Vmax. To reach Vmax quickly, enzyme should have its own half Vmax, but this value should be very less. Should be very less. Now, this half Vmax can also be represented by or Km. Now we will see what is this Km and how it is equal to half of the maximum velocity. So, what is Km? Km, already I have given you two different patterns of explanation. When we are talking about the substrates, Km can be defined as concentration of the substrate that permits the enzymes for forward reaction or to reach half of the maximum velocity, or the concentration of the substrates that have been occupied 50% of the active sites, or in terms of enzyme, affinity of the enzyme towards the substrate. What is meaning of affinity? Attraction. Means enzyme must be able to give its active sites for the substrates to come and bind there. Km is the concentration of the substrates that permits enzymes to reach half of Vmax. See, here we have written half of Vmax. The same thing I have written here. To reach a maximum velocity quickly within less time, enzyme should have its own half Vmax. Means within very less time, its 50% of the active sites should be able to get occupied by the substrates. If we write here half of the value of Vmax, and when we draw a horizontal line, how can we find this one in form of a graph? Means supposing this is complete Vmax, maximum velocity, and now we know the value. Take half of that value and represent on the y-axis, draw a horizontal line, then it touches the graph or the linear, the curve. That curve, the place of the curve or the point on the curve where it is corresponding to the x-axis, this corresponded point on the x-axis can be represented as Km. A small Km value indicates that enzyme requires less quantity of substrates, quantity or number of substrates to become or to reach the enzyme saturation, or to reach the enzyme saturation. What is meant by saturation? Saturation means getting occupied by the substrates on the active sites. That is termed as saturation. Means active sites getting occupied by substrates. That is termed as saturation. So, if Vmax has to be obtained very soon, then less number of substrates must occupy all available active sites and reach the maximum velocity. In such cases, we can say that less quantity of substrate are involving in the reaction to give out Km. In the sense, just a little bit more number of substrates than the less. Not completely 100% of the substrates, but a little bit more quantity of the substrate are giving maximum velocity or are responsible for reaching the maximum velocity of enzymatic reaction. So we can write this one in other terms as, so Vmax can also be reached with less substrates only, but a little bit more than the Km. But more than Km. Here we can take examples. How we are telling less quantity of the substrate is giving out a small Km like this. Glucokinase is one enzyme that is present in the liver and also in the beta cells of pancreas. It is considered to be having more Km value so that it is having less attraction towards the substrates. Has 10 millimolars of Km. We can also tell this is nothing but the maximum velocity. This is Vmax, also we can write Km. But we will write Km only per hour because the next topic we are going to discuss is under Km value. Another enzyme example is there, that is hexokinase, which is present in the muscles, blood, etc. But it is having very much small Km value so that it has high attraction towards the substrates. That substrate either for hexokinase or glucokinase is glucose only. 0.2 millimolars. This is considered as the Km value. What does this more Km value of glucose indicates? More Km value of glucokinase indicates that glucokinase is activated only in presence of more glucose molecules. Glucokinase is activated only in presence of more substrate. Also we can write, but directly we are going for what is that substrate. That substrate is nothing but glucose. Substrate. And glucokinase has high capacity for glucose. What does this capacity means? It means that glucokinase has the more reabsorption nature, means into the cell where this glucokinase is present. Capacity indicates more absorption or reabsorption of substrates into the cell. So there is difference between affinity of the enzyme towards the substrate or capacity of the enzyme towards the substrate. Here, during affinity, nothing support is given by any carrier particles or carrier proteins in the blood or in the cell. Directly, substrates like glucoses will come and bind to the active sites of the enzymes. But in case of absorption or reabsorption, this will take the support of carrier proteins like GLU, means glucose 4 or glucose 2, such type of carrier proteins, which we indicate as GLUV4, GLUV2 types of carrier proteins. Means without support of these type of proteins, the capacity of the enzyme will not be completed. But in case of affinity, means just simply attracting the molecules to bind to their active sites, nothing support of carrier proteins is required. Means here it is taking support of carrier proteins for reabsorption of glucose into the cell where this glucokinase is present. Means some energy or more of the activation energy of the substrate also might be involved. We will see some of the points regarding glucokinase and hexokinase. Glucokinase, its Km value is 10 millimolars. Next, it acts only on glucose. Glucokinase is stimulated by the insulin. Next, where is location of this glucokinase? So glucokinase is seen in are located in liver and beta cells of pancreas. It has less affinity for glucose. Means if the glucokinase has to reach the Km value or half of the maximum velocity, more amount of glucose molecules has to get involved in the reaction. Next one about hexokinase. Hexokinase half Vmax or Km value is 0.2. Means very less number of substrates can stimulate this hexokinase and make it to reach the half maximum velocity. It is seen or located in normal muscles and blood. It acts on glucose to involve in the glycolysis step and also acted upon by glucose 6-phosphate. When this hexokinase is acted upon by glucose 6-phosphate, we call it as feedback mechanism. That we will see the step. Glucose in presence of ATP and enzyme hexokinase gets converted into glucose 6-phosphate. But when any cell feels as if no need of more production of glucose 6-phosphate, then the product, so we can write here as product. The product itself comes back and binds to the active sites of hexokinase to stop the forward reaction. Such type of stopping is called as feedback inhibition or allosteric inhibition. So here stops forwarding reaction. If a question was asked, what is the reason of having less Km value for hexokinase? Still the answer will be, it has a nature of undergoing feedback mechanism or feedback inhibition by the product. So it is having less Km value. Now this process is called as feedback inhibition or allosteric inhibition. Some more points. Since it is having very less Km value, hexokinase has high affinity for the glucose molecule or the substrates. Due to less Km value, hexokinase has high affinity for substrate, that is glucose. Next, so that it can reach half of the maximum velocity in very less time. If we write here about hexokinase and glucose, hexokinase in very less time it can reach the maximum velocity, that is Vmax. Here we can write and here itself we can write Km value, but this black line we can put for glucose molecule, glucokinase. So this is for glucokinase and this is for hexokinase. If we compare the Km values and if we write the substrate concentration minimum values as 0 here, 5 here, 10, 15, 20 number of substrates, 25 like this, the Km value of glucokinase is 5 and here on the y-axis it will be according to the values that are represented here. But in case of y-axis we are writing about the velocity. What is the, in how much time, with how much speed the reaction is going on. In case of hexokinase, the Km value is very near to the 0 point. So it can be 0.2. or 0.3 also we can write, but already the calculated number of Km value of hexokinase is 0.2. So hexokinase is having high affinity for substrate because it is having less value. Now we can frame out a point. Km value is reverse to affinity. In the sense, more the affinity, less the Km value, more the Km value, less will be the affinity. Means more Km, less affinity. Less Km, more will be the affinity. Means attraction of the enzymes towards the substrates. Basing on the K1 means rate constant, K2, and here again at the denominator again K1. Another equation is also seen in some of the practice books, that is rate of reaction, that is maximum velocity, about maximum velocity. The equation can be V0 means velocity of the reaction at initial timing into whatever the Km value may be plus number of substrates that are getting involved in the reaction. So this will be the equation for Vmax. Next, for finding Km value from this enzyme plus substrate and enzyme substrate complex and the products, is there any equation? Means yes. K1 plus K2 again divided by K1. What is this numerator K1 indicating? It is indicating rate of forward reaction. This denominator K1 is indicating rate of reversible reaction. This can also be written as K minus 1 also. So here in the equation we can write like this K1 indicates forward reaction and this indicates reversible reaction. This indicates turnover number. This is just the simple point regarding Michaelis Menten equations and all those. There is another term used in the books for Km, that is simply Michaelis constant. If we see any word like this Michaelis constant, try to understand that the examiner is talking about Km value or half Vmax, or this same one can be written as Vmax by 2 also. Still the meaning will be regarding Km value only. We will see some of the points by linking up this Michaelis Menten constant with that of competitive and non-competitive inhibition. In competitive inhibition, if Km value is increased, then what about maximum velocity? Then Vmax will be. The question is, if the Km value is increased, then what about this? Without regard of Km value, already the total reaction has reached maximum velocity. After reaching only, we are again trying to find out the Km value. So, will be unaffected. Means after finding out the total Vmax, then only we are getting half of that Vmax. So, first of all, Vmax means complete reaction is happening. So, the question is, if this is increased, then what about maximum velocity? No, nothing will happen to maximum velocity because we are calculating the number. Later, if we increase this one also, maximum velocity will not be changed because there are no available active sites. Vmax can never be changed after completion of reaction, but during the reaction, Km value can be changed. That point I am going to write here. Vmax does not change, but during a reaction, because I'm telling here Km value can be changed because only up to here 50% of the active sites are occupied. Still there are some more active sites. So Km value can be increased or it can be changed. But during a reaction, Km value can be changed. Then what about the relationship between Km value and Vmax in non-competitive inhibition? In non-competitive inhibition, if Km value is less or decreased, sometimes they use the term, then Vmax also decreases. In a non-competitive inhibition, see, there is no competition, but still active sites are available. Then how the Vmax is getting decreased? Because in case of non-competitive inhibition, if you see the diagram, if you think this is the enzyme, the inhibitor is coming and binding at some other place. So the shape of the active sites are getting disturbed so that suitable substrates will not come and bind there. So the reaction cannot be proceeded. When active sites are there properly in proper shape, then the reaction can be processed. When active sites are not there, obviously velocity will be decreased. Vmax is decreased or less, we can write. Decreased or less. Again, the same non-competitive inhibition. If Km value is unaffected, then what about? If Km value is affected or decreased or whatever may happen to Km, there are no available active sites. So again, the maximum velocity will be less or decreased. If Km is unaffected, then Vmax is decreased or less. So in these two cases, availability of active sites are less. Availability of active sites is less. So this is about Michaelis-Menten equation or Michaelis-Menten constant. Now we will see different forms of enzymes and different uses of enzymes. In animal body, some types of enzymes are produced in inactive form and later they are getting activated by the chemical substances. Those are called as inactive enzymes. So, inactive enzymes are also called as proenzymes or zymogens. Also called as proenzymes or zymogens. One such example is pepsinogen. Example is pepsinogen, which is getting activated by the chemical hydrochloric acid and getting converted into pepsin, that is active form of enzyme. This pepsin enzyme is used to digest the proteins into peptones and proteins and peptides. This is one example. Another types of enzymes are isozymes. Isozymes. Isozymes means there are different types of enzymes, but those different types and different forms of enzymes are acting on only one type of substrate. Some enzymes in different structural forms act on same substrate. Here, during the conversion of pyruvic acid to lactic acid, Lactic dehydrogenase. It is existed in two different forms. Enzymes are lactic dehydrogenase. This lactic dehydrogenase, it exists in different structural forms. Next, another type of enzymes are renin, which is used to prepare or curdling of the milk. This is available in the market in the form of proteases, renin tablets and chymosin tablets, etc. Renin is used in cheese and curd making. Renin is available in tablet forms like renin tablet, chymosin tablets, next protease tablets. Renin was first extracted from the stomach of calf cells. Is extracted from the stomach of calf. So turnover number of carbonic anhydrase. It will be 6 minutes. Means within 6 minutes, all the substrates can be converted into products. Another point regarding the enzymes. The fastest enzyme is carbonic anhydrase. The smallest enzyme, lysozymes, are used to kill the bacteria. Next, largest enzyme, it will be catalase. But in case of human being, the largest enzyme is considered to be titin, which is used for the contraction of striated muscles passively. In human is, actually this much of depth is not necessary, just for your knowledge I am telling this point. Titin is in case of human that helps in contraction of striated muscles passively. The smallest enzyme already we have written as, not smallest, the slowly acting enzyme is lysozyme. Slowest enzyme, it is not the slowest enzyme, is the lysozyme, not the smallest enzyme. Next, the smallest enzyme is peroxidase. Another very important one is universal enzyme. Is trypsin. So these are the points related to enzymes. The last few points related to enzymes. What are different other types of enzymes? Their functions, largest, smallest, fastest and slowest type of enzymes. So now we have finished the Michaelis Menten constant and also whatever the extra points that are required from this concept. So by this we have finished biomolecules chapter.